Just bounce to this.
We take a look at some of the most incredible drones out there. At number 7, the dart throwing drone. I doubt that this thing will ever be released to the public, but this is still one of the neatest things out there. Now, this particular craft shoots sensor darts, which can embed themselves into soft targets up to 12 feet away. This is quite useful for setting up a communication network which can monitor a specific area, which is hard to reach. The firing mechanism is spring-loaded and triggered by an SMA actuator. So it is fairly accurate, with only a few inches of deviation at 12 feet. Now hopefully the team does not outfit the drone with actual tranquilizers, but the platform should have more autonomous sensors in the future. At number 6, the Radical Rocket. One of the most impressive homemade drones was shown on the Radical Rocket channel. It's basically a high-powered vector fan, which is encased in a CNC machined frame and cover. Its telemetry is fed back to a ground station, but it also incorporates a GPS, compass, and even crafty Falcon-style landing legs. Now, there were initially some yaw problems with the craft, but it can carry light payloads, and it's quite a bit safer than an exposed homemade multicopter. So make sure to check out the original link in my description for a more detailed breakdown of the build. Now we get to something that's a little bit quicker, and it's called the K-Racer. Now, Kawasaki has got into the realm of aerial vehicles, and they have built an overkill 300 horsepower supercharged helicopter. It uses multiple propulsion systems, including 2 forward props to handle yaw and torque balance. The main wings also enable high-speed flight, but no official top speed has been claimed just yet. Now, why did they build a crazy thing like this? Well, they plan to use the test results for developing more VTOL vehicles, which seems to be pursued by an endless list of companies now. So we'll just have to wait and see if this actually leads to a manned aircraft. Now we get to number 4, which is the Ghost 4, and it's one of the most advanced autonomous drones out there, which operates on the latest AI platform. This allows it to autonomously detect, classify, and track objects of interest in low bandwidth. Similar to the pursuit of level 5 autonomy in cars, I think that there's going to be a lot of improvement made in drone autonomy. It's just a matter of time. Nevertheless, the Ghost 4 can fly for over 100 minutes, and it's less audible than your typical multicopter. The drone also incorporates a neat rail which can carry extra batteries, sensors, and delivery payloads. And probably the neatest fact of all is that multiple ghosts can be controlled by one operator in a swarm mode, which is very interesting, and this exemplifies swarm potential. Now we get to number 3, and it's the Mod Quad. Now, scaling and putting modular robots together is a very challenging problem because performance usually does not correlate with the increase of mass. ModLab has tried to make this concept a little bit easier with individual yaw activation, which is left or right of direction of motion. It is done by relying on independent roll angles of each module, so each drone can actually tilt while being connected. Now, this might lead to something a little bit more advanced, kind of like the Dragon drone, because it can separate, but it also can join together for increased visibility and payloads. Once again, advanced AI autonomy can lead to new types of swarm drones, which were never conceived before. So there's some pretty neat things out there which work on swarm integration and AI autonomy. But there's also one other pivotal thing which I think is going to really enhance drone technology, and that is morphing capabilities. One way you can do this is increase the efficiency of winged aircraft. In this particular craft, both the V-tail and wings are made from a 3D printed lattice which is covered in a thin skin. These panels are made from thermoplastic materials which translates into load-carrying internal structures along with a more aerodynamic smooth surface. The model's wings are controlled by 8 servo motors, and this allows it to deflect over 48 millimeters. Now, this type of morphing ability can make the craft more fuel efficient and increase maneuverability, but it's still a long ways away from being implemented into large passenger aircraft. So once again, I'm going to get into something that's a little bit more renowned, and it's the Skydial X2. Now, most of you have probably heard of this drone and its renowned autonomy, but now a newer model has been released. Just like the consumer Skydial 2, the X2 uses multiple 4K cameras in conjunction with an NVIDIA Tegra X2 AI chip. This allows it to 3D map everything around it in real time and predict the paths of moving objects. This allows it to plot paths and fly autonomously through very complex environments. The cameras also can combine into a 360-degree view, and this allows you to zoom 100 times into any direction. So just like self-driving cars, drone autonomy is only going to improve, and I think drone flight will be more task-orientated rather than being manually controlled at a ground station. But let me know what you think about AI integration in aerial vehicles. So, once again, thanks for watching. Please like the video if you enjoyed it, and also make sure to subscribe to my channel.